My name is Innokenty Kantor, and I'm one of the scientists at the DanMAX beamline. DanMAX is a Danish beamline, so it's funded mostly from Danish sources. We will study different materials in real conditions, so we do a little bit less fundamental research and more practical applications. We will have two principal methods at the DanMAX beamline, which is powder diffraction and 3D tomography. Tomography is a method which allows us to see inside the object, because if you have a three-dimensional object like an apple, you can't see what's inside it unless you cut it. Sometimes it works, but sometimes you don't want to cut your sample because it's destroyed, or it is difficult, or you affect the sample while you're cutting it. For example, the apple starts to become brown when it's exposed to air, and the penetration power of hard X-rays allow us to look inside objects without actually cutting them, and also when they are in operation, like battery materials or some complex composite materials. During mechanical stress, we can see what happens with them inside. One of the key studies we want to do is study in situ fatigue damages of fiberglass composites, and this is a material which they use in blades of the large wind turbines. They fail at some point, and the manufacturer wants to know why they fail, on which place exactly, and that's one of the subjects we can do in situ. So the benefit of our facility is it's very bright source, so we have a lot of flux, so we can do the same things faster. We can do like 4D movies, so we can have 3D structure of this blade evolving in time while we stress it, for example. And the second method, which is called powder diffraction, it is a very powerful method for studying atomic structure of materials. So we can see what crystalline phases the sample has, how it crystallizes, how the phase transition occurs when we change external conditions. DanMAX is still under construction. We have more than a year before we'll see the first light. Our undulator is behind me, but it will be installed in the ring. This will be the strongest source of X-ray, the most bright source of X-ray in the world for a certain energy range. Just last week we signed a contract with the vendor for our X-ray optics, and so we hope that in 1 year we'll have it delivered, and a little bit later all the end station instruments will come, and maybe in early 2020 we'll have first users doing the first pilot experiments at DanMAX.